Okay, so now we need to accelerate and move on to something called z-scores. Okay? It's not that bad. You can do it. Another way to describe your performance is to tell how many standard deviations above or below the mean you are. This is called a standardized value or z-score. Okay? Now, if an observation is from a distribution that is known to, if you know the mean and the standard deviation, you can find the z-score using this little formula. The z-score is the value minus the mean divided by the standard deviation. All right, a standardized value is called a z-score. So let's do an example so you know what in the world I'm talking about. Below is a list of test grades for a class of 25 advanced algebra students. There it is. Jenny scored an 86 on the test. Now, the mean test score was 80, and the standard deviation was 6. Let's find Jenny's standardized test score, or z-score. So we're just going to practice using this formula for right now. Her standardized score would be, okay, according to the formula, we need to do the value minus the mean. So what did Jenny got an 86? So we need to do 86 minus the mean, which was 80, divided by the standard deviation, which was 6. So we just simply do that calculation. And so what do we get? It turns out to be 1. Okay? This means that Jenny's score was 1 standard deviation above the mean. Okay? It gives you a quick feel for how she did compared to the class. Put in terms of the picture like we've been doing. Remember, the mean is right here in the middle, and each one of these marks is a standard deviation. So we could say that on the map of data, Jenny fell right here. I'll just put a J right there. So there's Jenny. She fell 1 standard deviation above the mean. Okay, that's what the z-score tells you. Okay, so let's practice that. Find the z-score for the student who earned a 72. I'm going to pause the video while you do that real quick. Okay, so this z-score turned out to be negative 1.3. That means this child did a little bit worse than 1 standard deviation below the mean. Do we have a name of this kid? Johnny. You don't know a name? Okay.
More like disappointment.
Okay. Again, I could place this kid on the map, all right? This student would be about here on the distribution, all right? Because this is 1 standard deviation below the mean. All right, we call this kid Erica or something. No, this is Eric, not Erica. That's Eric, Erica's brother. Okay, her parents are not very creative, I guess. All right, so you can just get a quick feel. Sometimes just looking at a number, you don't know how a kid really did until you look at the z-score and you go, oh, okay, 1 standard deviation above the mean, 1 1/3 standard deviations below. Now you know how they stack up against their peers. All right, moving on. So on the advanced algebra test, on the next advanced algebra test, the mean score was 76 and the standard deviation was 4. When Jenny's parents asked how she did, her reply was, I did better than I did on the first test. I got an 82. What in the world is Jenny talking about? Well, like Jenny got an 82 this time. Last time she had an 86, remember? So why is she saying she did better this time? Why do you think she's saying she did better? Let's look at the z-score, is what I hear you saying. Let's look at the z-score, see how she stacked up to the rest of the class. Okay? So the z-score, we got to do the value minus the mean. So this time she got an 82, but this time the mean was 76. And the standard deviation was 4. All right, so what does this z-score turn out to be? 1.5. Okay, so this time she scored 1.5 standard deviations above the mean. Whereas last time she only scored 1 standard deviation above the mean. So that's how she can justify that compared to the rest of the class, she dominated more this time. Yeah, so we can write something like this. This time she scored 1.5 standard deviations above the mean. Last time she was only 1 standard deviation above the mean. Okay, so look at problem number 2. Eleanor's standardized score on the mathematics part of the SAT was 1.8. So this time they're giving us the z-score. The distribution of SAT scores in a reference population is symmetric and unimodal, okay, with a mean of, and here's the part where you start paying attention, the mean is 500, standard deviation of 100. What was Eleanor's actual SAT score? Well, remember how the formula works. So the formula for z-score is like this. The z-score is equal to the data value minus the mean divided by the standard deviation. Okay? So we're looking for x this time, and we're given everything else. So we are given that the standardized score is 1.8. So that means I've got 1.8 equals, okay, x minus. We're given that the mean is 500. And the standard deviation is 100. So it's just a matter of solving this equation. All right, so how will I solve this? Yeah, I would just multiply by 100 on both sides. Okay, multiply both sides by 100. That way these hundreds will sort of cancel each other out. 100 times 1.8 is just 180. Okay, so I have 180 is equal to x minus 500. Now what? True. Add 500 to both sides. Okay, and that should give me the value. All right, so 680. So that is her actual SAT score, working backwards. All right, now we're on the back of the page. Number 3. Gerald's standardized score on the math part of the da-da-da-da. All right, so this is a similar problem. So I'm going to pause the video and let you do this one by yourself. Okay? People on the internet, pause the video and work this problem out by yourself. Okay, so here again, we're given the standardized score. We're given the z-score of 1.5. That's going to equal the value minus the mean divided by the standard deviation. Okay, so I would multiply by 6 on both sides. Right? What do I get when I multiply by 1.5 by 6?
You get
9.
All right, so I have 9 is equal to x minus 18. So then I'm adding 18 on both sides. So that's 27, right?
Yeah.
Okay. All right, look at number 4. Judy, who is 25 years old, has her bone density measured. Her results indicate a bone density in the hip of 948 grams per square centimeter. A standardized score of negative 1.45. All right? In the reference population of 25-year-old women like Judy, the mean bone density is 956 grams per square centimeter. All right, Judy has not taken a statistics course in a few years. Explain to her in simple language what the z-score tells her about bone density. So has anybody internalized what z-score tells you? Like, what does z-score mean?
And she scored a 100.
Okay, can you give me that? There's like a phrase that is connected with z-score. Can you tell me?
Standard deviation.
It's a difference from the mean, but I want to hear that word. What's that word? Standard deviation. Put it all together.
How well you do compared to others.
It's how well you do compared to others, okay? Putting it all together, We're telling how well we're doing compared to others by telling how many standard deviations we are above or below the mean, putting it all together, okay? So in this case, her z-score of negative 1.45 is telling us that how's her bone density looking compared to other people? It's below, okay? It's not looking too good. Judy, your bone density is almost, 1.5 standard deviations below normal. Okay, in simple words, that's what we have to tell Judy. Okay, she's about 1.5 standard deviations below the mean. Okay. Now, use the information provided to calculate the standard deviation of bone density. Okay, so here's the key word. They're asking us to calculate the standard deviation. Find the standard deviation. So back to that z-score formula again. So again, we are given the z-score. So that goes right out front, negative 1.45. All right, that's where z-score goes. And then we're supposed to have the value minus the mean up here in the top. Mason, don't make me pause this video to wake you up. So we're supposed to do the value. Okay, her value was 948. Okay, do we know what the mean was?
956.
All right, they told us the mean was 956. So the only unknown is the standard deviation. Okay, so that's the thing that we need to find. Any guesses what I'm going to do right now based on what you've seen me do in other circumstances?
You got pause the swap them.
So you're going to pause the video and figure out what to do. We're going to do the swap thing. That was Scully's right. Yeah. We're going to swap these. Anytime we're trying to solve for a variable that's in the denominator, it's easy to reverse these two positions. Okay? That's what we love to do. So that's going to give us that the standard deviation is going to be, okay, out here, and the negative 1.45 is going to be down here. Okay? You might as well, what is 948 minus 956? Negative what?
8.
Negative 8? Okay, might as well go ahead and subtract those. So now we can go ahead and get the final answer. All right, what is negative 8 divided by negative 1.45? 5.52? Okay, so the standard deviation is 5.52.